Hello student, welcome to our physics discussion, that is physics in a smart way. We continue with our discussions on simple harmonic motion, that is branded as the topic of oscillation in your book. And as you have discussed in the last class, in the last video, we got a we got simple harmonic motion, and as I have told you, that is a sort of hypothetical motion which is created or imagined out of a real motion. The real motion is made by the body number one, which moves in a circular path in a anti-clockwise fashion, starting from this point, which I am showing, where the circle cuts the positive x-axis, and moves continuously with a constant speed with angular speed is omega, and the body number one moves around the circle, and thereby we say that executes uniform circular motion. We imagine drawing a perpendicular from that body number one onto x-axis, and the foot of the perpendicular is encircled as the number two, that is given the shape of another body, that is body number two, a small circle. And our motive was to observe the motion of the so-called foot of the perpendicular of the body number two, which for the time being we take as a real motion also. And as you know, as the body number one starts to move from this point, goes up and moves around the circle on and on and on, the body number two or the foot of the perpendicular that slides to and fro, right and left on the x-axis, and that executes uniform circular motion as I am showing it, okay, and its position at any time, its position is shown by its x-coordinate, because this is the origin, or the position vector. The position vector is always measured from the origin also. The position vector, r vector or x-coordinate, as you can see, as you can say, that is equal to a sine, sorry, not sine, but cos, a cos omega t we have learned in the last class. That was the equation number one. We have learned in the last class, where we know theta equal to omega t. That was a cos theta, basically theta equal to omega t. As you can clearly see here, that at time t equal to 0, the main body number one starts from here. At that time, theta also equal to 0, because angle is starting to be created then. So we know the foot of the perpendicular and the body will be matching at this point, will be at the same point. So thereby, at t equal to 0, which also can be given as theta equal to 0, and we know x equal to a. After some time, after the body has rotated up to the halfway length, when theta equal to 45 degree, we know there we say at t equal to theta equal to 45 degree. 45 degree means that is pi by 4, and we go in a reverse way, because theta equal to omega t, so t equal to theta by omega, so that is pi by 2 omega. Give it a pause and try to find out, try to ascertain the truth in this. There x equal to, when you put theta equal to 45 degrees, sine or cos 45 degree will be 1 by root 2. So there x equal to a by root 2. A by root 2. After some time, say theta is 60 degree. Theta is 60 degree. Normally we talk that as pi by 3. So that will be pi by 3 omega. time equal to pi by 3 omega. We'll be having x equal to, here you have to put cos 60. Cos 60 means half, that will be a by 2. A by 2 at time pi by 2 omega. It will be more clear if I mention that this is equal to 90 degree or pi by 2. We know cos 90, when you substitute here in the equation, the x coordinate, or so to say, the position vector will be giving us x equal to 0. The body will be, the foot of the perpendicular will be attaining, will be passing through the origin. Okay. As I mentioned this, we know we have created a situation where a very good graph can be made out of this. A very good graph can be made out of this. In fact, I am giving these values are now mentioned. I am giving it a pause and showing you the graph here. Showing you the graph here. Just give me a few seconds. Okay, so that is the graph. We got the x coordinate of the foot of the perpendicular or the position vector. We can say the value of the position vector are at on the x-axis here. The graph's x-axis here can be drawn with the help of theta, with the help of time. My point is that somebody taking it in terms of theta, then this will be pi by 2. This will be pi, that will be 3 pi by 2. Sorry. I have to write it about 3 pi by 2, and that will be 2 pi. If the same line or same axis is being taken by, is being written in terms of time, so that will be pi by 2 omega. Mark my words, pi by 2 omega. This will be pi by omega. That doesn't make so much of great difference. That will be 3 pi by 2 omega. That will be 2 pi by, this is 2 pi, of course, that will be 2 pi by omega. So normally the x-axis here, and don't confuse, that is graph's x-axis, not the x in the figure. In the figure where the main body and SHM is shown, the graph's x-axis can be drawn with on the basis of time or on the basis of angle. And you know, angle and time, they are related by the simple formula that theta equal to omega t. If you express it in terms of theta, so that will be 60 degree, 30 degree, and usually in scientific cases that is pi by 2, pi by 3, pi 2 pi, like that. If we express in terms of time, we know time equal to theta by omega, just to divide by another term, that is omega. You know, at the start, the position of the body will be, the position of the foot of the perpendicular here is at a distance a from the origin, at a distance a from the origin, and at pi by 2, when theta equal to pi by 2, time equal to pi by 2 omega, we know the position is 0. Then as the main body starts to pass to the second quadrant, you know, the x coordinate becomes negative. So here x becomes negative, and we know maximum x will be when the main body has covered an angle of pi radian or 180 degree at the center, that is here. In that way, you can find out all the things. Okay, I will not elaborate it, otherwise the video will be too long. So that is the graph of the x coordinate, or the graph of the position, or that is position time or position angle graph. That is the very fast graph of SHM. Okay, let me remove it. Let me remove it and mention two things. things here. If somebody asks you what is omega, then immediately you'll be tempted to say omega is angular speed of the main body. But at the start, we are taking the help of a prop of considering the main body, which is making uniform circular motion, and then the foot of the perpendicular and all those things. But after some time, we lose all those props. We consider only the motion of the foot of the perpendicular. The foot of the perpendicular, and considering this as a body, this as a real body, foot of the perpendicular just moves to and fro. That doesn't make that doesn't make any circular motion. Circular motion is already gone. Okay, so if you say omega is angular speed, people will laugh. So thereby the name has to be changed because there is no angle in strictly in the context of the so-called simple harmonic motion. So omega is known as angular frequency. Angular frequency. Okay. Here, the theta. When somebody shows theta and this circle, sorry, I have forgotten to mention it. This circle is known as reference circle. This circle is known as reference circle. Reference circle. Okay. If reference circle is known, then if somebody shows you better what is theta, then you may say that theta is the angle that the main body has made at the center with respect to the initial position at a time t. But if somebody is not showing you the reference circle, only shows you the SHM, we know SHM, there is no angle that is on a straight line. So thereby theta is known as phase of the SHM. Phase of the SHM. Simply you say phase, that is enough. Okay. Similarly, if somebody asks you what is A, we know A is the radius of the circle in which the main body moves. But here there is no main body. We know that in case of SHM, that is a midpoint of the motion. That is also known as the force center, but we'll be knowing it later. Midpoint of the motion. In case of SHM, from the extreme left to the extreme right, or the distance between the extremities is 2a. Or from the center, the body goes to the right a distance a, body goes to the left a distance a. That is the maximum displacement in either direction. And the central position is known as the mean position. The maximum displacement of the SHM making body in either direction from the mean position or the origin, and that distance is known as amplitude. Amplitude of SHM. Amplitude of SHM. The maximum displacement in either direction from the mean position. Mean position is where? Mean position is the origin. Okay. So today I think we must stop here because the video is not unnecessarily long. Next video, I shall be making you go through the other real issues of SHM. Thank you today. Please give my video a like if you like it, and subscribe to also if that comes to your benefit. Thank you again.